slide shows a comparison. That's the image coming out of the camera, and after we apply the image processing, this is the image we get, which is then sent to the blob detection algorithm so that we can get the exact coordinates of these blobs, which represent the finger. And when we get that information, we can apply that, manipulate that to give out some output depending on that. This is the top level flow chart for the program. The main core of our program is this library that we created. What it does is for every new image coming from the camera, it passes that through the image processing blob detection. And after getting all the information about the fingers on the table at a certain time, there are three main methods we're using to check the finger position on the table. And it checks for the finger gesture, such as a new finger has been applied on the table, or a finger that's already there has been moved, or a finger has been released from the table. These three gestures can completely sum up the entire finger that the user can give on the table, and depending on these gestures, we can give out the output based on the application. So if one of these methods find any new finger gesture on the table, then an event is triggered, and that event goes to the applications that are running on the table, and when the application sees it, as shown here, this is the flowchart for the applications running, and when we zoom in, if the application sees the event, then it can get the coordinates and all the necessary information like size of your blob or the fingertip, and based on that information, the application can process it to give out the interactive output on the table that user can, again, provide more input and get output. So we put up the hardware together, and we wrote the code library, we wrote a simple application. This is the video that we have. That our main goals were to apply multi-touch, multi-user, and affordability. We could clearly see that multi-touch was applied, and multi-user, me and Sato working on it at the same time, that was done too, and for the cost, I'll discuss in the next slide. But before that, I would like to make a point that this project that we did has the potential of being used in the future education system. We can easily add limitless number of applications. All the application needs to do is include one line of code to include the library, which gives the access to all the fingertips on the table. And just by doing that, different applications on math or science, physics can be used that can provide more interactivity to the user, and they can join in a group in a learning experience. That's the cost analysis. We spent a total of almost 12,000. That's including the labor and parts. But parts alone is only $714.73. For the labor, we spend a lot of time testing the hardware as well as testing the software, seeing what the exact placement would be, and seeing how the projector and camera should be placed so that the output would be on the exact right place. But if we were to produce this in a mass production, the price can go as low as $500 because we don't have to include as much cost for the labor, and when we produce in mass, the labor, even the parts cost will go down. If we compare this to some existing interactive tables, which range from around $7,000 to $10,000, this project has clearly potential for replacing the info education system as we saw. So we learned a lot of skills and lessons during this project. For the skills, we get experience with C# that weren't really familiar with, but it's a really fun language. It's an object-oriented language similar to Java. And we also understood the concept of multitask technology. Before this, it was just a technology that would amuse us. We were just being amazed at that technology, but we were actually able to implement that in our own table, writing our own application, and as you can see, it would actually work. For the lessons learned, we learned that we need to take into consideration the worst case scenario always. In our case, the worst case scenario was we started with 4 people, but during the middle of the semester, we lost the other 2 members. And they also had some parts that we already bought. So that made us spend a lot more time in the project and even buy different parts that we already had, but we had to order again. So from that, we also learned that all the resources that we're using in the project must be accessible to all the members at all the time, so the project wouldn't be delayed. And also we learned that each team member's contributions and responsibilities must be well documented and well tracked to see how well the project is going over the semester. These are some of the references. And before that, I would like to thank Dr. Katz and Dr. Nelson for being so supportive. Even after we lost the 2 members, we still worked on it and actually made it work. Thanks to them. And any